In previous videos, we have studied installations with three-phase supply, with users using two phases and a neutral to have two voltages available in the same home, 127 volts for low-consumption domestic equipment, and 220 volts for higher power appliances, such as for heat, ventilation, and air conditioning, electric stoves, clothes dryers, water heaters, etc. Some neighborhoods, mainly residential, where there are a few relatively high-consumption businesses, may be fed by a three-wire, single-phase system, which consists of two single-phase alternating current sources, distributed over three wires. Unlike the three-phase system, which supplies three phases, at 120 degrees apart, called L1, L2, and L3, in addition to a neutral wire. In the single-phase system, the voltage is delivered by the electricity company through a single-phase transformer with a 220-volt secondary winding, which has a central tap, which becomes the neutral wire. Power delivered by both ends of the secondary is 220 volts, while two 110-volt power sources, 180 degrees apart, are available by using the central tap as the neutral wire for both 110-volt sources. For the residential user, using relatively little power, as well as for the commercial user with medium consumption, the difference in degrees does not constitute a problem, but inconveniences arise for users who require high-power electric motors, since such motors are generally of the three-phase type in order to achieve greater efficiency. A user connected to the three-phase supply receives, between one phase and the other, 220 volts, while, using any of the phases with respect to the neutral, the user receives 127 volts. Using three-phase motors, you can get a better starting torque, a smaller motor size, since it does not require starting accessories, in addition to being much more efficient and having a much lower heat loss than a single-phase motor. However, for the user who has a three-wire single-phase system, another problem comes up. If you are close to the power company's high-voltage transformer, you may receive a phase-to-neutral voltage of around 135 volts, which can damage your low-power household appliances. Things become worse if you use high-consumption motors, since they will have to deal with 270 volts. An electric motor rated for 220 volts can operate, without much problem, up to about 240 volts. But 270 volts can seriously shorten its useful life, in addition to increasing power waste due to heating, making light bills become much more higher. If you are struggling with a situation like this, you should try connecting to a two-phase system to alleviate the problem. Another possible solution is to install additional transformers at your facility, in order to reduce the voltage applied to your electric motors. In the video description, I suggest a solution you can build yourself for reducing the voltage fed to each of the 220-volt loads. I hope this video is useful to you. Thanks for watching, and please, subscribe to my channel. Shava Tareen is inviting you.